In last class, we discussed three problems on continuity. Let's see this fourth question. If the function f of x is equal to 1 by mod x, where mod x is greater than or equal to 2, right? So whenever mod x is greater than or equal to 2, function definition is 1 by mod x. So it is piecewise defined function. For mod x greater than or equal to, separate definition. For mod x less than 2, the other definition. That is ax square plus 2b. Now here first I will tell you the key point. Function is differentiable on R. So we have a property that if f is differentiable at any point, then f is continuous at the same point, continuous at x equal to c. So this is the first key point of this problem. If f is differentiable, then f is continuous. We know that every differentiable function is always continuous. So here it is given that differentiability on R. So therefore, it gives us the information that f is also continuous on R. Okay. So that is the first point we are going to use to solve this problem. F is continuous on R also. Now the next one. Here I am going to remove first modulus. Now to remove modulus, you should know the definition of modulus. Mod x is x itself. Modulus of x is itself if x is positive. And modulus of x is minus x if x is negative. If x is greater than or equal to 0, mod x will write as it is. Means just we remove the mod and we write x. If x is negative, we write minus x. Okay. So now with this, so I'll tell you what are the key points of the problem. F is differentiable at x is equals to c, then f is continuous at x equal to c. Every differentiable function is always continuous. And the second condition is, second formula or rule you should know is, modulus of x is less than or equal to r, minus r is less than or equal to x is less than or equal to plus r. And mod x is greater than or equal to r, the inequality, if you remove the mod, you get x is less than or equal to r, x is greater than or equal to plus r. So you should know these rules before solving this problem. Okay. So the second one, what I am writing here, this is more frequently used inequality rule, very important rule. Okay. That's what you have to remember. Right. So remember these two rules. Using these two rules, I am going to solve this problem now. So first I'll remove mod. So f of x is equals to 1 by mod x. Mod x is greater than or equal to 2. Mod x is greater than or equal to, just now I told you, we get two results actually. X greater than or equal to 2, x less than or equal to minus 2. This is the solution of mod x is greater than or equal to 2. So I will divide this function into two cases. X is less than or equal to minus 2, one case I will take. X is greater than or equal to 2, greater than or equal to 2, other case. And one more case is there, mod x is less than 2. Mod x is less than 2 means minus 2 is less than, x is less than plus 2. Okay. So I'll write this case, minus 2 is less than, x is less than plus 2. Right. So whenever x is less than or equal to minus 2, if I say x is less than or equal to minus 2, means x is negative, right? So if x is negative, the definition of the function is 1 by mod x for that case. But x is negative. So mod x is what? Minus x. So we write in place of mod x, minus x. So I'll write that minus 1 by x. Next, for x is greater, this is coming, these two cases are coming from this. Mod x is greater than or equal to 2. So for these two cases, function is only 1 by mod x. So for both cases, you have to use the function 1 by mod x. Now, x is greater than or equal to 2 means what? X is positive. X is positive means mod x is going to be what? X. So I will write that 1 by x. After that, in between minus 2 to 2, this is the function for mod x is less than 2. So ax square plus 2b is the function for minus 2 is less than, x is less than plus 2. Now here it is given that f is continuous. Differentiability is given, directly not given continuous. Differentiability means continuity is also there. So f is continuous. If it is continuous everywhere, it is continuous at minus 2 also. It is continuous at 2 also. So I will use any one of that. You can use at minus 2 or you can use at 2. I will use 2 now. So f is continuous at x equal to 2. f is continuous at x equal to 2 means left hand limit at x equal to 2 should be equals to right hand limit at x is equals to 2. Also yes, of course, function value also equal. Now left hand limit at 2 means you substitute directly 2 in left of the function. Ax square plus b, you substitute x value 2. That gives you left hand limit x equals to 2. So a into 2 whole square plus 2b is equals to RHL means right hand limit at x equal to 2. So right hand limit at x equal to means right side of 2. Function is 1 by x. So here we have to substitute x value 2. So we get 1 by 2. So this implies 4a plus 2b is equals to 1 by 2. So this is the first condition. I got the relation between a and b. Now next we are going to use now differentiability also. F is differentiable, f is continuous. I used that continuity. I got one result and I will use the differentiability. Means it is differentiable. So it is differentiable on R means it is differentiable at every point. So find the derivative now. Derivative function f dash x is equal to, now you know the derivative of 1 by x. Yes or no? Derivative of 1 by x is what? Minus 1 by x square. So here 1 by x derivative is minus 1 by x square, but already you have minus, so it will become plus 1 by x square. So f dash x is 1 by x square for x is less than or equal to minus 2. And in the case of minus 2 to 2, function is ax square plus 2b and its derivative is 2ax. Because of x square derivative is 2x, 2b derivative constant, constant derivative 0. Here minus 2 is less than, x is less than plus 2. Now x is greater than or equal to 2. Function is 1 by x. And you know the 1 by x derivative? What is that? Minus 1 by x square. So I will write minus 1 by x square. This is for x is greater than or equal to 2. So we got derivative function. So f is differentiable everywhere means differentiable at every point. So it should be differentiable at 2 also. It is differentiable at 2 means left hand derivative at 2 should be equal to right hand derivative at 2. Now left hand derivative, here you can use the function 2ax. Left of 2 function is 2ax. Function means derivative function. So left hand derivative should be equal to right hand derivative at x is equals to 2. So what is left hand derivative at 2? You substitute here 2a into 2, which is 4a, is equal to right hand derivative at 2 is what? We have to substitute 2 here. X is equal to 2 here. 2 square 4. So minus 1 by 4. From this you are going to get the value a is equal to minus 1 by 16. Now use this a value minus 1 by 16 here. So you get 4a means 4 into minus 1 by 16 plus 2b is equals to 1 by 2. So 4 4 is minus 1 by 4. So 2b is equal to 1 by 2 plus 1 by 4. If you take 4 LCM, you get 3 by 4. So therefore b is equals to 3 by 8. Now what is the question? He is asking what is the value of 48 into a plus b. So we got a value, b value, just a simple calculation now. 48 into a plus b, which is 48 into a value minus 1 by 16 plus b value 3 by 8. If you take 16 LCM, so 48, 16 LCM, you get minus 1 plus 3 2s, right? So 6 minus 1, 5, 16 3s, 5 3s, 15. So this is the value of 48 into a plus b. So what are the key points we used to solve this problem? That is, if f is differentiable on R, f is continuous on R also. Differentiability is always implies continuity. And simple inequality rules also we used. Mod x is less than or equal to R implies minus r is less than or equal to x is less than or equal to plus r, and mod x is greater than or equal to r if you have x is greater than or equal to r, x is less than or equal to minus r. The two simple inequality rules.